Hello folks, my name is Sarvesh, and today I'll be sharing you a method to do a flutter and divergence analysis using finsim software. So, it is quite an old software, and it is very useful software for doing flutter dimension analysis to make sure that your rocket will sustain whatever loads and the fluctuations that it will encounter in the air while it is flying. So, let's just dive into it. Firstly, you will see this kind of rectangle in which you have to select two quantities. So, first quantity is actually the altitude from where you want to launch your rocket. So, it is actually your geographical location of your launch pad. So, if your launch pad is uh, 1K feet above the sea level, you can choose that. So right now for demonstration purpose, I'm choosing that. So next you have to choose the units in which you want to work. Let's say I'm choosing meter per second. The third thing you have to do is here, you have to choose fin material. But before that, you might want to give the dimension to your fins. So for that, firstly, you have to open a window from here. So yeah, this kind of window will pop up. So here you can see the units are in inches. So you have to be careful about that. So if you are designing your model in some another unit, you have to convert that unit uh, into the inches and be ready with those values to fill over here. So first thing we gonna do is we will choose the maximum ball diameters. So let's say for my rocket it was 150 so I already know what is its conversion in inches, so it was 5.9055. So I have filled that over here. So next thing is fin angle of attack. So I'm just keeping it 0 for now. uh, Here you have to give a description to your fins. So I'm giving name fins. uh, let's say here you have to specify number of fins. Let's say I have 4 fins. uh, I'm just filling all the values fast. So root chord 10, let's say dip chord 6, then semi span 5, sweep angle 3, and thickness point 2. So like that you can fill out your own values, and you can choose multiple fins at a time for doing a simultaneous analysis. Let's say it is fin set 1, so I'm again choosing 6 fins, doing some fancy stuff. Then root chord as 6, tip chord 7, um, let's say 3 2, uh, then point 5. I'm making some kind of fancy fin, but that is okay. This is for demonstration purpose only. So after filling all these values, you have to click on return to the main screen button, and now you can see over here some values are popping up. I'll explain in a while what are those values are, but before that we have to choose fin material. So here I find this list pretty exhaustive, referring to the material which we usually use as part of fin. So right now I'll be demonstrating you this two fins for the CFRP, that is a carbon fiber reinforced polymer. So uh, you can see that there are a lot of options in CFRP also. Like I can see CFRP T300, CFRP AS, and many more lying around. So right now I don't know what to choose. If you're someone who doesn't know what to choose, then you can choose maybe all of them. You can click on this dimension window, and you can choose up to 6 fins. So you can choose all the fins. You can name the fins by their material, keep all the dimensions same, and you can compare all the values. Right now I'm just keeping two fin set for my analysis. Let's say I choose CFRP T300 for this one and CFRP AS for this one. Now from here, uh, I'm getting pretty weird values, obviously, because my values were not that good or near to what usually is. So right now I'm just making all the values same for both the pins so that we can compare them uh, side by side. Yes. So now all the values are equal. So all the values are equal. I have chosen CFRP T300 and CFRP AS materials for fins, and now I'm getting pretty decent relative values for divergence and flutter. So this indicate that given your rocket dimension and material, your there is high chance that um, your fin will encounter divergence at if your velocity is above these values. So you have to make sure that your rocket maximum velocity is well below the divergence and flutter velocity. So what you can do, let's say I'm taking safety factor of 1.5, and by the simulation, I know my rocket's maximum velocity is 300. So the divergent flutter velocity should be way higher than 450 in this case. And you can do this for different material, and uh, you can fine tune your thickness or whatever values you want to fine tune. You can do that. Let's say uh, here I can see that uh, for CFRPAS, my divergence is occurring at 5048 and my thickness is zero point 0.2. Let's say I don't need that thick fin. So I want to reduce my value. So let me check whether 0.16 thickness satisfying my need or no. It is well below the desired value. So let me check with 1.7. So uh, it is also less. So let's check with 1.8. So from here, what I did is uh, I saw that if I choose my thickness as 0.18, it is very close but higher than uh, the safety value, that is 450 meter per second. So uh, like this you can fine tune your model and choose the appropriate dimension for your model. And that's it for today. I hope you had a great time learning this, and do apply it in your projects, and all the best.